All right, so welcome to the video on sigma or summation notation notes. So that's what we're going to learn about today. So first, before we do that, let's talk about what a series is. We've already covered what a sequence is in our notes. Here's an example of a sequence: 1, 2, 3, 4, 5. A series is when you add the terms of a sequence. So 1 plus 2 plus 3 plus 4 plus 5, okay? So what we can do to represent a series is we can use what's called sigma notation or summation notation. So it says to indicate that we want to add up all the terms of this sequence and make it a series, we could use the Greek letter sigma. So the Greek letter sigma is right there. It is an S in the Greek alphabet, so think of it as an S for sum. Okay, so whenever you see a sigma, it means to add them up. Okay, it means the sum. Here's a little note on summations. It says summations, the sum of the first n terms of a sequence is represented by. So here is how we write the sum of the first n terms. So you have your sigma. I don't. Let me have my little tracer out here. Okay, this means add up all the terms, okay? And don't look at this right now for a second because that's just telling you what to do. So this right here is what we're looking at. So this says you're going to add up all your terms. That's what summation means. That's what sigma means, okay? K is called the index of the summation. This is the upper limit. And then whatever K is equal to, which it could be any letter K, is the lower limit. So this is 1. So this tells us that we want to plug in 1 through n. So if there was a 6 up here, we'd be plugging in 1, 2, 3, 4, 5, and 6. And you plug it into your equation, and then you add them all up. So this would be our equation. So that means that we would find a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub whatever, okay? And then add up all those solutions to each one of those and get your final summation. Okay. So what we're going to do here is we are going to write in summation notation, okay? So it says example, write the series 1 plus 2 plus 3 plus 4 plus 5 using sigma notation, okay? So that was the one that we just started with. So we're going to start by writing a sigma, okay? All right, so now we want to write a rule, okay? We want to write a rule right here. And when you're writing a rule, we want to see if it's arithmetic or geometric, which we know how to do both of those, but we're going to focus mostly on, sorry, my video paused, but we're going to actually focus, we're going to look at both today, and then we'll look at each one more specifically. Okay, so here where I have it circled, we are going to want to write a rule. So if you look to see what's happening here, we have to figure out what the pattern is. So if we look and see what the pattern is, this is +1, +1, +1, +1. So there is a pattern of +1. That means it's arithmetic. So let's go ahead and write an arithmetic rule. So to write an arithmetic rule, we have a sub n is equal to our first term, which is 1, plus n minus 1 times our difference, which is 1. Clean that up so it looks like slope-intercept form. So we have 1 plus n minus 1, and we just get n. Okay, so our rule is a sub n is equal to n, right? It makes sense. Our first term is 1, our second term is 2, 3, 4, 5. So what you're going to do is you're going to write your rule right here. So our rule is n, and then, or you could use any variable you want. You can use k, you can use p, you can use, but I tend to use n or k a lot, okay? And I didn't mean to say okay as we're doing that. So now down here, we're going to say n equals, and you're going to say the first number that you're plugging in. So we'll be plugging in 1 to get our first term. And then what we plug in here, and it's what we plug in here to get our first term. So we plug in 1 right there to get this. And then what we plug in here to get this answer. And what we plug in there to get that answer is 5. So we're going to put 5 up here. Not in love with this first example because based on this, it could look like you write this number here and you write this number here, which is not what you do, okay? It's what you plug in to get that value. And it's just because this is n that's happening, okay? But there is our summation notation or sigma notation. All right, let's go ahead and continue to try some of these. So this next one says write using sigma notation. So let's go ahead and do that. So we need our sigma first off, okay? And then now we need our rule. So we need to decide what pattern is happening here. So if you look, this is plus 2, plus 2, plus 2, okay? So we know that this is arithmetic, so let's write an arithmetic rule off to the side. I actually want to do it in a different color. Okay. All right, we have a sub n is equal to our first term plus n minus 1 times our difference, which is 2. Clean this up. We have 2 plus 2n minus 2, which the rule is then a sub n is equal to 2n. Okay, so this time our rule is 2n. And now down here, we're going to say n equals, and then what we plug in here to get 2. So we would have to plug in 1 to get 2. And then what we plug in here to get 30. So that looks like I was saying plug in 30. So what we plug in there to get 30. So we have to plug in 15 there to get 30. Now also, I want to keep in mind, like if my rule was more complicated, like if my rule is 1/7 n minus 6, and I was like, what do I plug in here to get 30? It's not that clear. So then you could set it equal to 30 and solve what you would have to get, right? So mathematically, writing an equation, instead of saying, what do I plug in there to get that? I can say, okay, 2n is equal to 30 when n is 15. But here is your sigma notation or your summation notation. All right, let's move on to the next one here. Okay, so I want to write this in summation or sigma notation also. So what I want to do is I want to decide if this is arithmetic or geometric. So first thing I notice is that 3 of them are fractions and 1 is not. So I could make this a fraction, right? And now I'm like, okay, now they're all fractions. So you can look at this as one of 2 ways. You can do the numerator separate from the denominator. But I see that all of the numerators are 1. So like that I can just see that this I can treat as a geometric function, right? I can see that the denominators is times 3 times 3 times 3, but the numerator I could also say is times 3 times 3 times 3. Technically, or not times 3 times 3, times 1 times 1 times 1 times 1. So you can look at both the numerator and denominator geometric. So times the numerator by 1, the denominator by 3, or times it by 1/3. Or you can just say the numerator is always 1 and the denominator is geometric. It's up to you, okay? So I'm going to do it, I'll do it both ways because, hey, why not, okay? So first I'll recognize it, the whole thing is geometric and it's times 1/3 times 1/3 times 1/3. That means that I can write a rule. A sub n is equal to, since it's geometric, it's my first term, which is 1, times my ratio, which is 1/3 to the n minus 1 power. So I can do it that way and say that is my rule. So I could write sigma, and then 1 times 1/3 to the n minus 1. And technically, I don't need that 1 in front. It's 1 times that, right? And then I can say n equals, I plug in 1 to get the first term, and recall or make sure we realize if I plug in 1 right here, this becomes 0. Anything to the 0 power is 1, and then 1 times 1 is 1. So that is a 1 there. And then what do I need to plug in here to get? And then notice it doesn't stop. It goes on forever and ever. So that's infinitely. So that's one way of doing it. And now let me show you a couple other ways. Because if you were working ahead of me and you're like, I got it, but my answer doesn't look like yours, let's make sure we realize that this also works. So another way that we can do this is we can say, all right, my pattern I notice is that the numerator is always 1. And then the denominator is times 3 times 3 times 3. So that times 3 is to the nth power. So I can say I have 1/3 to the nth power, right? So that's works. And then I say n is equal to, if I plug in 1 here, I do not get 1, right? So I have an option. I can change this to n minus 1 and then say when I plug in 1, right? And so now when I plug in 1, I get 3 to the 0 power, which is 1, and that works now, and I can say it goes on infinitely. Or, so this works, or, okay, or let's go back to what we had moments ago. I had 1 over 3 to the nth, okay? Or what I can do is I can say n equals, and I can say instead of starting by plugging in 1, I can plug in 0, right? So then when I plug in 0, I get 3 to the 0 power, which is 1, and then it goes on infinitely. So all 3 of these work, okay? All 3 of these work. I like the first one the best because it just like goes along with what we've been doing if we say it's geometric, but the other 2 work just fine, okay? All right, when writing these rules, we would like for you to always start with n equals 1 or n equals 0. Sometimes the directions say, assume the first term is n equals 1, and then you have to start with n equals 1. So keep that in mind also. Okay, last one, so like this one right here, okay? Use sigma notation to write a summation for this. Assume that 1/4 is the first term in the sequence where n is equal to 1, which is the lower limit. So it's telling us now that we have to do that. Let me put my pen back on here. So we're gonna have our sigma, and it's saying you have to do n equals 1. You can't do n equals 0 like I did in the last one. All right, so if you look at this one, how it's different from the last one, the numerators aren't all 1, so I can't do it I can't do it like I did this one right here, okay? I have to do the numerator separately from the denominator. So I want to look for a pattern for the numerator, and I want to look at a pattern for the denominator, okay? So let's start with the numerator, okay? The numerator is more difficult as I look at it because I see that this is, let's just do it anyways. I was gonna say, so let's start with the denominator instead, but no, I'm gonna start with the numerator. It's times 3, which doesn't work. So now I have to switch to addition, and then I look at addition, and all of a sudden I'm like, it's not arithmetic, okay? But if you look, there might still be a pattern here. This is plus 8, and then this is plus 16. So there is a pattern here because now it is times 2, times 2, times 2. So the first difference has a geometric ratio. And that's, I've never said those words before in a sentence. I'm making that language up, but it all works out here. So what I'm gonna do, okay, is I'm coming up a rule with the second one. So since I see that there's some sort of geometric where it's times 2, I'm gonna start with the numerator. I'm gonna say 2 to the n for the numerator. So now I'm just looking at the numerator and I'm like, okay, if I plug in 1 here, I have to get 1. And it's like, that's not working. So what I can change this to is I can change it to n minus 1. So now when I plug in 1, I get 1. But then if I go to plug in 2, I don't get 3. So that's not working, right? So I'm like thinking around here and I go, okay, wait, I could do, I plug in 1 here, I get 2, but then I minus 1 from the entire answer, right? And I know that it has to have something added, or I should have said that. I know that it has to have something added or subtracted on it because it's not, if this was not here, then I'd be trying just for a geometric 2 to the n. But there's something else going on that has an arithmetic change to it, right? So I see, not arithmetic, it has another change to it. So I know that if I do 2 to the n, I'm gonna get that times 2, but then I have to adjust. So if I plug in 1, I get 2, but then I need to get 1, so I subtract 1, and now the first numerator works. Let's plug in 2 and see if we get 3. If we plug in 2, 2 squared is 4, 4 minus 1 is 3, that works. Let's check one more. If I plug in 3, I get 8, 8 minus 1 is 7, boom, we found the numerator, okay? And if you were like, what just happened? I need to rewatch that. Let me explain again. If you got it, fast forward through my second explanation. I saw that there was a pattern here, but it wasn't a first difference. I looked and I saw that the second difference was actually a second common ratio of multiply by 2. So then I said, I know that I have this 2 to the n. But it couldn't just be a 2 to the n or 2 to the n minus 1 because it wasn't a first difference. So then I said something's got to change there. So I started it with the 2 to the n. I plugged in 1 and I saw that I got 2 and I needed to get 1. So I subtracted 1 and then checked it for the rest. Okay, denominator, easier. I can tell just by looking at it because I can see that it's times 2. All right, times 2, times 2, times 2. So this is geometric just by itself. So I can write a rule for the denominator, which I should probably do this in a different color so that it doesn't blend with my work doesn't blend in 2 different ways. So my denominator, I know that I have a rule for my denominator and that it's geometric. So I know it's a sub n is equal to the first term, which is 4, times the ratio, which is 2 to the n minus 1 power. If you want to check it, you can. If you plug in 1, you get 4. If you plug in 2, you get 8. It works, right? So 4 times 2 to the n minus 1 power. All right, lastly, I have to figure out what term this is, and that is not difficult because it does have an end that I see. There's no like ... anywhere. This is the first term, second term, third term, fourth term, fifth term. So this is going to be a 5 that I would have to plug in to get my last term. And you could always double check to see if it's true. 2 to the 5th power is 32, minus 1 is 31. In the denominator, if I plug in a 5 there, I get 2 to the 4th power, which is 16, times 4, which is 64. That took the longest explanation, but it is the most difficult one by far. Kind of have to think through, not kind of have to, you have to think through it. All right, next what I want to show you how to do these in your calculator. So if you are allowed to use your calculator on some sort of entrance exam or standardized test, I want to make sure you know that you can easily throw these in your calculator. Unfortunately, on our test, it's not going to let you do that. It's going to ask specifically for you, like you could always use your calculator to check your answers, but we're going to ask you specifically to use formulas that we teach you. And by we, I mean me. Okay, so here's how you would put this in your calculator. Because doing this by hand would take a while. All right, so if I wanted to do the summation of 1 divided by n factorial for the first 8 terms, that means plug in 0, plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, plug in 6, plug in 7, plug in 8, find those solutions and then add them all up. Takes a long time, right? Just by hand. So in our calculator, how we can do this is that you could hit the math button, which is the 3rd button down on the left. Then we want a summation. So summation, you can keep toggling down here, and you should find option 0 as summation, and you hit enter. So then what we're going to do here is that we want to put n equals 0 or x equals 0. So I'm going to do x equals 0 in your denominator, in my, not denominator, on the bottom of the summation. And then your upper summation is 8, so we're going to put 8 there. And then we're going to put our rule, which is 1 divided by x factorial. We want to make sure our x factorial is in parentheses just to make sure that it does divided by x factorial and not divided by x, and then take that answer and do factorial. To get factorial, we're going to hit math and then move over to probability, and the 4th option down is factorial. And close your parentheses on that and then push enter. It tells us that the sum would be 2.7, and then we're going to round to 3 decimals, so 718. It doesn't specifically say round to 3 decimals. I'm telling you that on your test, it will say round to 3 decimals unless otherwise, if you need to. Another thing that we could do is we could check to see if this is convertible into a fraction by hitting math, enter, enter, and it's not. So we'll just leave it as 2.718. Okay, so here's what I mean. Could I use my calculator to do all 3 of these now? Yes, but the directions tells me that I cannot. It says write out and compute each sum, okay? So I'm going to explain the second one before I explain the first one, which I wish that they were switched, but I don't care that they're not, because I feel like it makes more sense doing the second one. The first one makes more sense after doing the second one. All right, so let's go ahead and do the second one. So please realize what this says. It says plug in 3 into this rule. See what you get. Plug in 4, plug in 5, and plug in 6. And then once you get those values, add them all up, and that's the answer. So we're going to go ahead and do this. We're going to start by plugging in 3. So we're going to do 2 times 3 plus 3. And then I'm going to write out what that is. Okay, so that's 6 plus 3, which is 9. And then I'm going to add. I'm going to plug in 4, 5, and 6. So I'm going to do 2 times 4 plus 3. Oops, I don't know. I haven't actually written that. I'm going to do 2 times 5 plus 3. And I'm going to do 2 times 6 plus 3. I'm writing those out just so that I don't get lost. In the future, if you just, I'll highlight what I'm talking about. All right, so I have 9 plus 11 plus 13 plus 15. In the future, when I say write out a compute, all you have to do is this, okay? So that's writing it out, and then computing, okay? Computing is getting the actual answer. So 9 plus 11 is 20, then we got 33, 48. So the answer is 48. So another way of getting these values without showing this work, obviously you can plug it in your head, right? But getting the first one, 2 times 3 is 6, 6 plus 3 is 9. So I have the 9, and then know that there's a common difference of 2, so 9, 11, 13, 15, all right? All right, so on this one here, you'll see why it makes more sense for me to explain the first one. I need to plug in 1 through 7. So plugging in 1 into this equation or expression, I get 5, right? Plus, I'm going to plug in 2, and I get 5. I plug in 3, and I automatically get 5. So see why I wanted to do the other one first? 5, 5. I need to do it 7 times. 3, 4, 5, 6, 7. 35. Once again, you might be saying, do we have to write that out? The directions say so. Write out and compute. All right, last one in this section, and then I'm going to have you go ahead and try the rest on your own. I didn't do the practice yet, but I will actually continue the video and show you the practice, okay? If you want to just check your answers with the key when we're done, you can. All right, write out and compute. So we're going to plug in 0. Negative 1 to the 0 power is 1 times. Plugging in 0 here, 0 plus 1 is 1. 2 to the first power is 2, so I get 2. Plus, and now I'm going to plug in 1. Plugging in 1, I get negative 1. And then plugging in 2, plugging in 2, I get 2 plus 1 is 3. 2 to the third power, or sorry, I am plugging in 1. Oh my gosh, I got lost in my own head because I'm not writing enough down. Plugging in 1, I get 1 plus 1 is 2. 2 squared is 4. Negative 1 times 4 is negative 4. Okay? So now I could say, all right, I got to put, this was plugging in 1. This was sorry, that was not plugging in 1. That's why I got my confused in my head. That's plugging in 0. That's plugging in 1. I have to plug in 2, 3, 4, and 5. But also if you recognize what's happening, you can just get the values quicker. So I recognize what's happening, and all that I need for full credit with writing on computing are these numbers down here, okay? So this work you don't necessarily have to do. So I know that this is alternate signs. So it's going to go plus, minus, plus, minus, plus, minus, or minus, plus, minus, plus, minus, plus, depending on what it is. And then I know that this means to multiply by 2, all right? So I can get these entries without having to actually plug in 2, plug in 3, plug in 4, plug in 5. So it's going to go, this one's going to be negative, or sorry, this one's going to be positive since the last one was negative, and then times 2 is 8. Plus, this one's going to be negative since the last one's positive, and then times 2 is negative 16. Positive 32, negative 64. Add all those up, and you get, let's see, 2 and negative 4 is negative 2, plus 8 is 6, minus 16 is negative 10, plus 32 is 22, minus 64 is negative 42. And you could also use your calculator, right? Like no one says you can't. Calculator is allowed. Okay. All right, so the rest is for you to practice on your own. I am going to, you know what? No, I'm not going to show you how to do all of these. I will post my answer key with my work so you can see how you